Hi dear students, how are you? All of you, pleasant evening. Right, my dear students. So, in this series, what we have been seeing at Infinity Learn by Sri Chaitanya, the course that we are being giving for JEE. From my side, in the last two sessions, I have done limits, then continuity and differentiability yesterday, right? In today's session, we are going to see the next topic, that is methods of differentiation, or simply we say differentiation or derivative something, right. So, followed by, my dear students, you see those who did not see the limits and continuity and differentiability, please watch those two videos, so which are very much helpful. So, I got good remarks from the students that the two videos are very much helpful, right. So, my dear students, in this session we are going to highlight the important methods of differentiation, right. So, the title you might have seen, methods of differentiation JEE 22 previous year questions, right. Before that, all of you please subscribe to our channel Infinity Learn JEE. Please subscribe and please encourage your brothers and sisters, friends also to subscribe to our channel. So, the more you encourage, the more we will give, right, in terms of number of classes and everything, right. The next, my dear students, coming to the topic, methods of differentiation is, you see, generally the question from this topic will be bit lengthy, but you see, for every engineer, see, the basic tool is derivative. To understand physics, to understand many things, actually for a science student, differentiation is the basic tool one has to learn, without which you cannot be a perfect engineer, right. So, not only for JEE, anyhow you have to master differentiation, right. I guess you know, I assume that you revised, you are perfect with all the basic formulae. Now, the question to find the derivative may be given in many ways. Based on our comfort, we can see the questions will be the first type of question, I can say, explicit differentiation model. That means y is equal to some function will be given. This is the basic model, so we can do this. Second one is implicit differentiation, where the function will be like connecting with x and y, f of xy equal to 0. I think everybody knows the shortcut to find the derivative in this case, which is my dy by dx you can write here like minus dou f by dou x by dou f by dou y. This is the shortcut, dear students. So, the students who are listening for the first time this shortcut, you may be confused what is this dou f by dou x. I will explain, which is partial derivative. In fact, I will take and I will explain this in the problem what I am going to discuss now. The third one is parametric differentiation, where x and y will be present in other parameter, and derivative of a function with respect to other. Logarithmic differentiation, mostly when variable power variable is given. Derivatives by trigonometric substitution, sometimes the inverse trigonometric functions are given, or if we substitute variables by some trigonometric functions, the problem gets simplified. So, that one. Then higher order derivative means second derivative, third derivative idea, the next miscellaneous problems. Certain problems can be done, they will be a bit different, so how to handle those. Precisely, I can say in the topic methods of differentiation, we can have 8 models. Here itself I can say derivative of inverse of a function, derivative of a determinant, all these models come in the last stage. But most important thing, these 1 to 6 models will be reflecting, that means you can see the previous year questions, these models are continuously reflecting in JEE Main. So, let us have a look on these problems, my dear students. Are you all ready? Before that, you see, before going to solve these problems, point number 1 prerequisite is, I assume that, or you have to prepare all the basic formulae of derivatives of the function. Point number 1, if you are thorough, please once recall. Then number 2, even algebra of derivative like derivative of u into v, u by v or chain rule kind of things, you must master this. After this you can attempt the problems. Dear students, you just see this, the first question that is given. You see in this question, derivative of tan inverse of something with respect to another function at x is equal to 1 by 2. This is the problem given. Fine, 2020 question. We need to find the derivative. Fine, derivative of a function with respect to other modalities. Moreover, we can't take the derivative directly because it is tan inverse or something bit complicated, right? Then you just think of what substitution can be given. And one more important point, suppose if you want to give x is equal to some tan theta here, it may not work here. You no need to give the same substitution at both the places. Do remember, you can give any substitution. Here in this particular problem, as 1 plus x square is given, I choose x is equal to tan theta because 1 plus tan square theta is an easy expression. So in the first case, choose x is equal to tan theta, so that you see what it becomes. 1 plus tan square theta is secant square theta under root secant theta minus 1 by tan theta, that is 1 minus cos theta by sin theta by cos theta. This expression becomes, you know, this is 2 sin square theta by 2 sin theta by 2 cos theta by 2, which is, you can say, tan theta by 2. So tan inverse of tan theta by 2 you can take like theta by 2. So finally this is going to be theta by 2, where theta is here, x is tan theta, theta by 2 in the sense you can write tan inverse x by 2. So that means this total expression is simplified like tan inverse x by 2, dear students. Then this is easier than that. In the same way, you can also go with this. Here you see I want to go with x is sin theta. Why? You see 1 minus x square is there, which becomes cos theta here. 1 minus 2 sin square theta formula is also there. Already theta is used. You can take some alpha here. In this particular expression, I take x is equal to sin alpha. So that this is 2 sin alpha cos alpha, which is sin 2 alpha by cos 2 alpha, tan 2 alpha. Tan inverse of tan 2 alpha will become 2 alpha, whereas 2 alpha in the sense you can write sin inverse x. So this total expression is simplified as 2 sin inverse x. Now I just want derivative of first expression with respect to second. I told you derivative of a function with respect to other means simply take the derivative of this. Half tan inverse x derivative is 1 by 1 plus x square by, with respect to this means 2 into sin inverse x derivative is 1 by root of 1 minus x square. This is the derivative, friends. Now you have to put x is equal to 1 by 2. Now substitute and do, this becomes 1 by 4 multiplied by, when it is 1 by 4, this is 5 by 4, so 4 by 5 into, this becomes root of 1 minus x square, which is root 3 by 2, yes, which I can say root 3 by 10 is the answer. You see, I have written number of steps also, a few, because one thing, certain calculations you must be habituated to do orally. You see, in this problem you might have learnt two things. First of all, derivative of a function with respect to other model. Second thing, as inverse trigonometric functions are given with lengthier one, you can give trigonometric substitution. And third point, you no need to give the same substitution. Here you see I have given x is tan theta, here I have given x is sin alpha. You can give separate. Ultimately this function is simplified like this, second function is simplified like this. So you can take the derivative. Clear, dear students? The problem is bit time taking. I can say it may take 2 to 3 minutes in the exam, but no issue, you can do it. Okay, fine. Next, you see this question, friends. This is another question, 2020 question. This is a plus root 2b cos x multiplied by a minus root 2b cos y is equal to a square minus b square, where a, b are constant. I want, you see, dx by dy. Fine, we call it as implicit function. X and y are mixed together. I can't write y is equal to something. So, in this case, friends, you see, let me write the formula. The formula is, if the function is like implicit function like f of x y equal to 0, the shortcut is dy by dx is equal to minus dou f by dou x by dou f by dou y. What do you mean by dou f by dou x? Partial derivative with respect to x means it is also just like derivative, but do remember, yeah, you have to feel only x as the variable, all the other variables are constant in this case. Whereas if you want, you are taking dou f by dou y, just feel like only y is the derivative, remaining are all constants. Okay. Now for this problem, I am just going to take, I just write minus of a square minus b square equal to 0. So it is like f of x y equal to 0, right. Then next, I want dy by dx, my dear friends. So according to the formula, minus dou f by dou x means you are taking partial derivative with respect to x. So treat y as constant. I am taking derivative, friends, this is a number here. Now a minus root 2b cos y, okay, into its derivative, a derivative 0, root 2b into cos x derivative is minus sin x, okay, by, because a square minus b square derivative becomes 0. Now dou f by dou y, take with respect to y, means this part is constant, a plus root 2b cos x into its derivative with respect to y, a derivative 0 minus root 2b into cos y derivative is minus sin y. Yeah, this is the derivative. Derivative is done. Of course, root 2b can be cancelled. This minus and minus gets cancelled. Now you have to substitute the derivative at pi by 4 comma pi by 4, means x value pi by 4, y value is also pi by 4. Substitute, friends. If when you substitute y as pi by 4, 1 by root 2 gets cancelled, a minus b by this becomes a plus b, and this is sin 45, 1 by root 2 both get cancelled. This is a minus b by a plus b. This is what we say dy by dx, but please do remember he asked dx by dy, dx by dy. Dx by dy is quite reverse of this, a plus b by a minus b, that is it. So dear friends, this is, in this problem we have recollected the result of, what is that? Implicit differentiation. If the function is like f of x y equal to 0, dy by dx is minus dou f by dou x by dou f by dou y, that is the formula. Clear, dear student? So second model I have recollected, with the help of which you can do n number of problems, right. Then next, dear students, you see this question, y is sigma k into cos inverse of some expression is given, we want dy by dx at x is equal to 0. Can we simplify this? One important observation in this problem is 3 by 5 here, 4 by 5 here. What can you say? Is there any observation, friends? These are two numbers such that sum of their squares is 1. So I can select, no, there exists some fixed theta such that this is going to be sin theta, other is cos theta, or if this is cos theta, other is sin theta. I want to write cos inverse of, so 3 by 5 let me write as cos theta, 4 by 5 will be sin theta. Such theta exists in 0 to 2 pi definitely, because sum of their squares is 1. So, cos theta cos kx minus sin theta sin kx means this total expression I can write cos of kx plus theta. Do remember, theta is a fixed constant because the numbers are constant. So, cos inverse of cos, so time being let me take y is equal to sigma k is equal to 1 to 6, you can say kx plus theta, where theta is some constant. So, you just apply sigma, friends. Sigma is on, of course, into k is also there, into k is also there. So, sigma k is equal to 1 to 6 k square x plus sigma k is equal to 1 to 6, theta will be here into k. Now, this is y. You see, variable is present only here, this is a constant. You just take derivative with respect to x, dy by dx I want, okay. So, this becomes 0, sigma k square, the sigma is on only k but not on x, so x is independent, into sigma k square 1 to 6 means n into n plus 1 into 2n plus 1 by 6, so which is 91 is going to be the derivative. This is 91x whose derivative is 91 directly. So, that is all. Even at x is equal to 0, it is 91. So, here more or less in this problem he did not test the derivative nature, simple simplification he has given. So, I have chosen this is cos theta sin theta. So, I can write cos of a plus b, cos inverse of cos, of course, even though there are many cases as there is no clarity, it is nearby theta, we can see that it is in 0 to 2 pi, 0 to pi range. So, I can say because theta is around some first quadrant it is, so x is also nearby 0, I can say. So, this is cos inverse of cos x, I have written x itself. So, k square x plus k theta. Now, if I apply sigma, it comes like this. Here some number into x plus some number, derivative means x coefficient itself, 91 is the answer. Okay, dear students, fine. The next one, you see this question, this is another important model. So far I have covered 3 models, my dear students. You see, x is 2 sin theta minus sin 2 theta, y is also given in terms of theta, then I want to find d square y by dx square. Friends, this is called parametric differentiation. X is expressed in terms of theta, y is expressed in terms of theta. If you are asked to find dy by dx, that is parametric differentiation. One important model in parametric differentiation, he will ask the second derivative, that is the speciality of this problem. First derivative is standard, you can find, he will ask the second derivative, that is very important model where most of the students will feel difficult with this problem. So, first what you need to do is find the first derivative. So, in case of these, how will you find dy by dx, friends? By parametric differentiation, it is dy by d theta by dx by d theta, right? So, first you find dy by d theta. So, 2 cos theta derivative is minus sin theta minus cos 2 theta derivative is minus sin 2 theta into 2. This is dy by d theta, right, by dx by d theta. So, its derivative 2 sin theta derivative cos theta minus sin 2 theta derivative cos 2 theta into 2. This is dx by d theta, right. Now, you can further simplify even this is, okay, you can take out 2, this is sin 2 theta minus sin theta by, this is you can say cos theta minus cos 2 theta. You can apply trigonometric transformations, sin c minus sin d will become 2 cos c plus d by 2 sin c minus d by 2. Here also the same. Here minus 2 or 2 sin c plus d by 2 sin d minus c by 2 you will get. Okay, because of course this minus and this, you can say these two get cancelled. I can say along with minus you will get 2 gets cancelled, you can say cot of c plus d by 2, that is 3 theta by 2 you will get. This is dy by dx. Now d square y by dx square means taking its derivative again with respect to x, that is the point. So let me write here d square y by dx square is take its derivative with respect to x, cot 3 theta by 2 derivative minus cosecant square 3 theta by 2. Okay, let me write here multiplied by 3 theta by 2 derivative 3 by 2 multiplied by, I am taking derivative with respect to x whereas internal function is theta, d theta by dx you have to write, my dear friends. This is your answer. If you confuse here in writing d theta by dx, Jai Hind, so be careful. So this is friends minus cosecant square 3 theta by 2 into 3 by 2, from where will you get d theta by dx? Here you have written dx by d theta, it is reciprocal only, that is 1 by 2 cos theta minus 2 cos 2 theta. Yes, this is going to be the derivative, my dear friends. I want this derivative when theta is pi. Substitute theta is pi, cosecant square 3 pi by 2 is 1, so this is minus 1, this is 3 by 4, this is minus 1, you will get minus gets cancel 3 by 4 and this I think you will get minus 3 by 8 you will get here. The answer would be 3 by 8. Okay, fine dear students. So this is another important model. What is the beauty in this problem? This is parametric differentiation, second derivative. Find the first derivative, then take the derivative with respect to x. The first derivative will be in terms of theta. So after taking derivative you write d theta by dx. Friends, for your reference, let me show the problem that we have done. So you see, so far we have covered explicit differentiation model, it is a regular one. Implicit we have covered, parametric we have covered. In the first problem itself we got derivative of a function with respect to other, derivative by trigonometric substitution. You see, in 2020 questions I have taken just 5-6 questions. In those questions almost all the models are covered. Of course, logarithmic differentiation model yet to come. Higher order derivative is also done. Just now we have done second derivative, right? You see, in this problem, derivative of a function with respect to other logic, trigonometric substitution. Next, this is explicit implicit differentiation. Next, of course, this is simplification related, and then parametric differentiation. In parametric differentiation, second derivative is very, very important. Okay friends, chalo, next problem. Simplification based, right. Before that, my dear friends, y of alpha is given, just try. You see, dear student, if you just observe JEE main questions, even advanced also, if the derivative related question comes, mostly you just think of within these 6-7 models what method can be applied. So if really if you get this question in advance, you are so lucky, you can definitely find the derivative, because derivative must be one of our favorite tools, right? In the same way, even in mails also, we are getting question from methods of differentiation. So you please do this, practice it, don't forget to practice. Coming to this, right dear students, 1 plus tan square alpha is there. I think by this time you know how to solve this, right? You might have got the idea, right? How? You just write cot alpha as 1 by tan alpha. So what will you get, friends? 1 plus tan square alpha by tan alpha, this 1 plus tan square alpha got cancelled. So y of alpha you will get square root of 2 cot alpha plus cosecant square alpha. That is the thing, friends. Yes. Now what can we do? Shall we go with direct derivative? 1 second. Cosecant square alpha you can write 1 plus cot square alpha, right. So, this is going to be friends root of 2 cot alpha plus 1 plus cot square alpha, which is friends 1 plus cot alpha whole square it is. Whole square under root means modulus of 1 plus cot alpha it is. I think you got my point, because it is perfect square, 1 plus cot alpha whole square. Root of x square is, my dear students, root of x square is not x, mod x, do remember, that is very important point. So, that point you see, we have done n number of problems based on that in algebra, in differentiation, in integration, many places it is very much helpful, dear friends. Root of x square is mod x. So, y of alpha is given. Now, he is asking alpha around 5 pi by 6. So, derivative at 5 pi by 6 means alpha is not exactly 5 pi by 6, because you know derivative is also a limit. Alpha is almost 5 pi by 6, which is 150 degrees, where cot alpha will be, I can say, around minus root 3. 1 plus minus root 3 is a negative quantity. So, I can write it as minus 1 minus cot alpha. Yes, this is going to be y of alpha, my dear friends. Hi dear viewers. So, some students are watching this. Hi, how are you? Right, fine. Right, chalo. So, 1 minus cot alpha, right. Now, I just want derivative, simple. Minus 1 derivative is 0, minus cot alpha derivative is minus cosecant square alpha, which becomes plus cosecant square alpha at 5 pi by 6, which I can say 1 by root 2 whole square, 1 by 4, no sign, it becomes 4. That is all. Clear, dear students? So, matter of simplification. If you are not thorough with this concept, that is root of x square is mod x, if you are not clear with this basic concept, undoubtedly you are going to get a wrong answer, because minus 4 is also waiting here for you, right. I think, dear students, I think you know this point, 99 percentile, to score 99 percentile subject wise, you see the mark, if you just see in math, physics, chemistry at any random paper in JEE mains, if you see, the less mark will be in math. So, scoring in math in JEE main, not only JEE main, even in advanced, is comparatively difficult, because in math most of the students go with wrong options. They do not know that it is wrong, they feel that they are correct, they opt the negative also. So, this is why be thorough with the fundamental concept, that is very important. Fine, anyhow, no problem. The next question, you see this question, yeah, it is given y into root of 1 minus x square, where k is constant, y of 1 by 2 is minus 1 by 4. I want to find dy by dx at x is equal to 1 by 2. Yeah, fine, simple, you can do this. I think by this time you are getting the idea, right. You can do this like, you see, you can write this function like y into root of 1 minus x square plus x into root of 1 minus y square minus k equal to 0. You see, x and y are mixed together. So, why can't we go with which method? It is implicit differentiation. You just go with dy by dx is equal to minus, next dou f by dou x by dou f by dou y. Apply dou f by dou x with respect to x I am doing. So, y is constant, y into root x square derivative 1 by root of 1 minus x square, root x derivative 1 by 2 root x into its derivative minus 2x, plus you are taking derivative with respect to x. So, root of 1 minus y square you write, and x derivative is 1. In the same way, here also you take the derivative with respect to y, minus dou f by dou x by dou f by dou y. Y means x is constant. So, 1 minus x square into y derivative 1 plus x is constant, root y derivative 1 by 2 root of 1 minus y square into minus 2y. Okay. Fine. Now is simple, x you put 1 by 2, y you put minus 1 by 4, you will get the derivative. He is asking derivative at 1 by 2, that is all, you will get the answer, that is it. So, matter is only one point, implicit differentiation, x, y are mixed together, just direct ahead, simple shortcut, minus dou f by dou x by dou f by dou y. Okay. Right, dear students. You see this question? Yeah. He is asking here to find e power y plus xy is equal to e is the function. By seeing this function itself, you will get the idea it is an implicit function. We can take the derivative by implicit differentiation. Now, I want dy by dx as well as d square y by dx square. Fine. At x is equal to 0, that is also there. Fine. So, first of all, you take the derivative implicit differentiation dy by dx, you try to find, friends, minus dou f by dou x. Okay. With respect to x, I am doing e power y is constant 0. So, y is constant, x derivative 1 by dou f by dou y. I am taking with respect to y, e power y derivative e power y, and xy derivative means x is constant, y derivative is 1. This is dy by dx. What about dy by dx at x is equal to 0? If you substitute x is equal to 0, x is 0, what about y? You substitute here, when x is 0, e power y is equal to e, so y must be 1, dear friend. Yes, that means when x is 0, y is 1, you substitute here, you are going to get, this is going to be minus 1 by, so this is e. Minus 1 by e is the first derivative, so these two options are ruled out, right. The next, my dear friends, these are the two things. Now, I want second derivative. When first derivative is known, which is in xy, but still you can find second derivative, you can just find second derivative like, it is like minus u by v, no problem, do v derivative of u, let me write in detail here. So, minus y by e power y plus x. So, yeah, I'll go with minus y by e power y plus x. Y dash is minus y by e power y plus x. You want second derivative, right? So, y double dash is v derivative of u minus u derivative of v e power y derivative y dash plus x derivative 1 by v square. This is the thing, friends. I want this expression value at x is equal to 0. You know, when x is equal to 0, y is equal to 1. Y dash value is also minus 1 by e. Now, you just substitute these values, x is equal to 0, x becomes 0, y becomes 1, y dash becomes minus 1 by e, you substitute, you will get the answer as b. That is all. Nothing special in this problem, very regular one, but little patience is required, little caution is required in the exam. You have to do the simplification carefully, because you see all the options are almost same with plus minus difference. Be careful with simplifications, okay. Right, dear students. Next, we shall go with this question. This is a simple one you can do. So, tan inverse of, I can say, sin x minus tan inverse is there. You can divide the numerator and denominator with cos x, so that this becomes tan x minus 1 by tan x plus 1, which is, I can say, this part becomes tan of x minus pi by 4. Yes. So, tan inverse of tan of x minus pi by 4, this function becomes, I can say x minus pi by 4. Derivative of a function with respect to x by 2. Simple. So, derivative of this with respect to x by 2. What a simple question here. Derivative of this is 1, x by 2 derivative is 1 by 2. So, the answer is 2. That is all. Yes, easy question, right? That is it. The next, dear students. Yeah. So, this is a function. So, 2x power 2y is 4 into e power 2x minus 2y. Then find that expression. Whenever variable power variable is given, if at all you want to find the derivative, better you go with logarithm. Just take logarithm on both sides. You will get 2y into log of 2x is equal to log 4 plus 2x minus 2y. That is all. Log 4, if you write like 2 square, you can write y into log of 2x is equal to log 2 plus x minus y, we can write. I just want dy by dx into 1 plus 2x whole square, this expression I want. Yeah. So, you can do one thing, you see y term you can bring here, you can take y common, 1 plus log 2x is equal to x plus log 2. Okay. Y is going to be, you can write x plus log 2 by 1 plus log 2x. This is y. Now you just find its derivative, y dash, like u by v you can do v, derivative of u is 1 minus u, derivative of v is 1 derivative 0, log 2x derivative 1 by 2x into 2 by v square, 1 plus log 2x whole square. You just bring 1 plus log 2x whole square this side, you will get, dear students, 1 plus log 2x. You can just simplify here, 2 gets cancelled, here 1 gets cancelled, log 2x minus log 2 by x you will get. So, x log 2x minus log 2 by x, option A is the right answer. Matter of simplification. So, the idea is, dear students, whenever variable power variable comes, simply take the logarithm and just take the derivative, isn't it? Next, you see, you can observe most of the times we are trying to complete the problem less than 1 minute or 90 seconds. We can do, friends. Yeah, this is the question, interesting question really, 2019 question it is. F is a function from R to R. I said miscellaneous problems, functional relations related question it is. Yeah friends, you just see f of x is given, he wants f of 2, but function is not given completely. This problem can be handled in this way, f dash of 1 is some number, say this is a, f double dash of 2 is some number, let it be b, f triple dash of 3 is some number, say it is c. So, f of x is going to be x cube plus ax square plus bx plus c. Now, find its derivative first, but he does not give any information about f of x, he is asking us to find f of 2, right. So, fine, you just take f dash x, which is 3x square plus 2ax plus b, but we know that f dash of 1 is a, put x is equal to 1, this is a, this is 3, this is 2a, this is b. So, from this you can say, friends, a plus b is going to be minus 3, first equation. Then again you take the derivative, f double dash of x is 6x plus 2a. I know that f double dash of 2 is b, put x is equal to 2, b is equal to 12 plus 2a. So, you can write 2a minus b is equal to minus 12. From this friends, 3a is minus 15, a is minus 5. Once a is minus 5, b is equal to 2. A and b we got. Now you just take third derivative, dear students. F triple dash of x is nothing but 6. For any x it is 6. So, c value is 6. C value is 6. So, f of x now you know, which is x cube plus a means minus 5x square plus b is 2x plus c is plus 6. Now, f of x is completely known. Can't you find f of 2? Put x is equal to 2, you got the answer. That is it. 8 and 6, that is 14 plus 4, which is 18 minus 20 minus 2 is the answer. That is it. The idea is, this is even this kind of question you can find in previous advance also. It is an important question given in 2019. Let it be a, this is b, this is c, these are 3 numbers. Now f of x is a polynomial. Take first derivative, put 1 because you know f dash of 1 is a. Second derivative, put x is equal to 2 because f dash of 2 is b. That is it, simple problem. Right, dear students? Fine. Yeah. Next, this question, this already we have discussed. X is equal to 3 tan t, y is equal to 3 secant t, d square y by dx square at x is t is equal to pi by 4. I already told you that parametric differentiation second derivative case is interesting, important. See, given in 2019 also, the same it is reflected in 2020 even, right. So, dear students, yeah, right, fine. So, can you do this problem? Need to do, you just find dy by dx, which will be in terms of t. Again take derivative and you write dt by dx comes. If you want me to do, I will, otherwise try dy by dx, right. Dy by dt is 3, secant x derivative is secant x tan x, secant t tan t by dx by dt, 3 tan t derivative is secant square t, 3 gets cancelled, secant t gets cancelled, this is sin by cos, 1 by cos, so sin t it is, right. Now, I want its derivative with respect to x, that is d square y by dx square. Sin t derivative is cos t into t derivative with respect to x is dt by dx. This is important step in this particular problem. So, cos t is fine, yes, and what can you say about dt by dx? Dx by dt already I have written 3 secant square t. So, dt by dx is 1 by 3 secant square t, okay. So, which becomes friends 1 by 3 into cos cube t, right, cos cube t. He is asking a t is equal to pi by 4, 1 by root 2 whole cube is 1 by 2 root 2. So, 6 root 2, 1 by 6 root 2 is the answer. A simple and standard question. This kind of model I have seen in n number of exams. Parametric differentiation, that to second derivative, okay, do remember. Again in 2021, at least in one of the papers that kind of question reflects, you can ask me, okay, I am sure. Right, dear students, you see this is also a standard question. Y square plus log of cos square x is given as y, implicit function, right. He is asking y double dash of 0 something, y dash of 0. You just take the derivative, y square derivative 2y y dash plus 2 log of cos x derivative 1 by cos x derivative minus sin x is equal to y dash. According to the problem, when x is 0, what is y? You put x is equal to 0, cos 0 is 1, log 1 is 0, y square is equal to y you will get. That means y can be 0 or 1, two possibilities will be. when x is 0, y can be 0 or 1, two possibilities, fine. Now you want y dash of 0, put y dash of 0, y dash of 0, 2, suppose it is 0, y of 0, 2 into 0 into y dash of 0 plus cos 0 is 1, sin 0 is 0, this term will become 0 is equal to y dash of 0. So in this case you will get y dash of 0 is 0, right. Suppose y of 0 is 1, 2 into 1 into y dash of 0 is equal to y dash of 0. Even in this case also y dash of 0 is 0. So either of the cases I can say y dash of 0 is 0, we are sure. In the same way, if you want y dash of 0 is 0, that option is not there. So we need y double dash of 0, again find second derivative here. This is going to be 2y y dash, I can say minus 2 tan x is equal to y dash. Just apply derivative, friends. This is again like uy, u derivative of v plus v derivative of u minus 2 secant square x is equal to y double dash. Put x is equal to 0, my dear friends. Y of 0 is 0, this is gone, this is 0, this is also gone, this is 2 minus 2, y double dash of 0. So y double dash of 0 is going to be 2, dear friends. So I can say 1 is, so I can go with option C, that is it. So friends, in the same way, so this problem I think you got clear. Functional relation, not a functional relation, it is implicit function. I have taken derivative and I have observed, right. Then you see this question, friends. So x power k plus y power k is a power k, a, k are constants. What a simple question it is. How do you find dy by dx here, friends? I told you this is implicit function. So minus dou f by dou x means x is the only variable, take derivative k into x power k minus 1, rest of all 0, by dou f by dou y. So only y is variable, k into y power k minus 1. So these two got cancelled. So dy by dx plus x by y power k minus 1, but he said y by x power. So can I write y by x power 1 minus k is equal to 0? Yes. This 1 minus k he has given like 1 by 3. So 1 minus k is 1 by 3, k is going to be 2 by 3. That's all. Easy problem, it's very easy. 2020 question, yes, yes, right. So dear students, before this I want to come to the first page again. I already told you, you see, in differentiation, if you could do at least 4 or 5 problems for each modal, it is enough, you can comfortably attempt the derivatives related question in the exam. You see, once again, the basic thing what you need to do is, before I conclude, first you go through all the important formulae of the derivatives, that is step 1. Step 2, including algebra of derivatives like u plus v, u minus v, u into v, u by v derivative function, those form chain rule, you also practice those. Then next, explicit differentiation stands for the basic standard questions, y is equal to something will be given, those questions. Then implicit differentiation, I have already given the shortcut. Parametric differentiation, in this second derivative is the most important one. Then derivative of a function with respect to other, we have done some questions. Logarithmic differentiation when variable power variable is given, or sometimes products converted into addition also we use, but that is a rare case. Then derivative by trigonometric substitution also we have done n number of questions. Higher order derivative we have seen, second derivative, miscellaneous questions. Apart from this, there are few special questions like, you see, inverse of a function, derivative we need to find when f inverse related, and another some questions are there on this, and derivative of a determinant and miscellaneous questions will be, those you can do. So dear students, with these you can attempt almost all the questions related to derivatives, right dear students. So this is our Telegram group, yeah, Infinity Learn JEE Telegram channel. Please join with us, encourage us. We provide you extraordinary, unbelievable, fantastic questions, and as a study kind of inputs we will give, right dear students. Yeah, Infinity Learn, crack JEE, subscribe, like, comment, share, right. I am here, Basheer, math faculty at Infinity Learn by Sri Chaitanya. See you dear friends, Monday again will come with some beautiful topic, maybe applications of derivative let us take up. Until then, signing off, take care, bye bye, see you.